Hey, it's Dr. Pat here, and we are talking compositions of functions right now. Composition of functions. So, composition functions, what we mean by is we're going to be combining functions. We're going to be combining results of functions. So it can be more than just the formulas, but we'll be working formulas over and over again. And what we're doing is we're going to be using the output from the first function as the input for the next function. Okay, or what I like to say is I'm just going to plug the result that I get from the first formula, and I'm going to plug that into the second formula for my calculation. And that's what it's all about. It's about using the results from the first one. Our notation, as you see up here, this is the notation that we'll use. So what we're seeing at here is when I see this f of g, see that g is inside the parentheses here? That's meaning that's the first function. So g is my first function I'll be playing with. And so I get the result of the g function, gonna plug it into the f function. So it kind of works backwards in this way. And this is another notation that we have for it as the composition. And so we got this little open circle here. If it's a closed circle, that would be multiplying the two results. But with an open circle, that's composition. Works the same way. Backwards, gonna take the g result and plug it into the f function. So that's kind of the result, and that's how we'll play with it. To start off with this, let's just do some table of data, and we'll just kind of answer these questions, and then we'll work it. Hey, just to start off with it, I just want to make sure that we've got this down. And so if I were to ask you the question, hey, what is f of 2? You would know right away, like, hey, that's my x value. That's the input. The input's 2. We're looking for the result of f of 2. We're looking for the output when x is 2. So you would go to this table. Here's 2 is the x. The y value would be 7. So just a reminder, that's what we'll be doing there. So working the input, trying to find out the output. That's the game. All right. So our first step over here, our first example, is going to take the x value 4. And we're going to figure out what the output is for the f function. So we go over here to the table. I find my x value of 4. And I find my output is going to be 5. So this piece right here, f of 4, is the same thing as 5. So by doing that quick calculation, quick result, what I'm doing is I'm replacing this package, and I'm just rewriting it right there as 5. Okay, so f of 4 is the same thing as, it is asking what's the output when my x is 4? Well, that output is 5. So I'm just now going to write the output itself rather than that whole notation. And so our next step is, hey, what's the output for the g function when the input is 5? So I go over to this table here. I find my x value is 5. I go to the g column, and I see my output would be 0. So the answer to this one would be 0. Okay, playing the second one here. Notice this time the g of 4 is inside the parentheses. So what we're asking for is what's the output for the g function when x is 4? So I go here, x is 4. I go to the g column, and I see a 2. So what's happening is this g of 4 here has an output of 2. So it's the same thing as writing f of 2 in this case, because that's what that output is. Our last step is asking what's the output when x is 2 on the f function? So I go to x is 2. I find, hey, my f column here, my output is 7. So there's my result, 7. Okay, so that's what we got going there. Now, let's try this other example. So we've been putting one result, using it into the other function. You could actually do it on itself. So this question is asking, what's the result of the f function when I got 3? That gives me 6. So then I go here and I say, hey, what's f of 6? And so then I go back to my table here, and I see my x value of 6, my new input. And then I find out what my output is. It's 1. So what I did here is I started with an input of 3, got an output of 6, and now used that output as the new input for the f function, and I got a last result, the final answer of 1. Okay, so this one here, this bottom example, has got 3 of them together. So we're just going to have to do this repeatedly. Don't worry about it. It's kind of weird. It's freaky maybe to look at, but it's doable. So my first stage right here is to figure out the innermost, just like order of operation, that whole PEMDAS thing. Do parentheses first. You do the innermost parentheses to do your calculations. And so what I'm looking at here is this innermost one right here. That's what I'm looking right. And I'm asking myself, okay, what is f of 0? What's the output for the f function when x is 0? So I got x is 0. I'm looking at the f function. My output is 3. So then I would have a new write-up, and this would be my new write-up. So all I did was, where I saw an f of 0, I put what its input is, so that's where that piece is coming from right there. So my next layer is I got to figure out what's the output for the g function when x is 3. And so I'm looking at that, and I'm looking at the x value 3, and I go to the g and I see 6, so I replace it with 6. And my last thing to do here is I'm taking 6, plugging it into the f function, once again trying to find the output on the f function when x is 6, and that gives me 1, and so there's my final answer. And so that's how we play the game with tables of data. If you're using the set kind of way of showing two sets with the diagram kind of thing with arrows, one of the key things to remember is that we've got two functions here. I've got the f formula that's using these first 3 arrows, and then I've got the g formula, which is using these 5 arrows. Okay, so just a reminder of how this game plays. Like if I'm doing f of 3, that means I'm using the f function. I'm starting here at 3, following that arrow, and it's telling me associated with that input of 3 is an output of A. If I'm doing g of d, that means I'm using the g function over here, and I'm starting with an input of d, and then I'm following the arrow to its output, which would be z in this case. Now I'm playing with another one. I got f of b. So I go to the f function. I'm looking over here in my input, and I got a problem. B is not my input. B is an output. So this notation right here is undefined because I don't have a B as my input, as my x's in a way. Okay, so my input's not set up there, so it's undefined. Doesn't exist. Or if you like to use D and E out there, go with it. All right, so I'm going to do this bottom one first and let's see what happens. So I'm looking at, first do the inside. So I'm looking for the output when my input's 1 using the f function. So I start off here at 1, I follow the arrow, goes to C, so that means C is the output for f of 1. So now I am playing with g of c. So now I'm asking the question using the g formula relationship, what is the output for C that's associated with it, that corresponds with it. So I'm looking at here at C, and I bounce over, follow the arrow, and that gives me a Z. Good to go. And so there's my answer for that one. For this last problem, I'm looking at an input of 1, and I got to go to the G function to find the output. Okay, so the G function, I'm looking at my input for the G function right here, and I do not see a 1. Looks like 1 is the input for F. 1 is not the input for G, so this is also another one of those does not exist undefined type of situations. Okay, and so that's just the beginning of composition of functions, just looking at them in terms of numerically with tables and this kind of more of a set notation. Part B, I'll be looking at compositions with formulas with functions. Thanks. Have a good day.